Previous class we discussed about the total internal reflection, critical angle. Now we discuss about the simple experiment to determine the thickness to know the glass slab or that refractive index of the medium to be determined. So it is a glass, its refractive index we know 1.5. That we have to prove experimentally. So here one of the simple experiments, and the experiment is important one. So what is this aim of this experiment? To find the refractive index of RI of glass slab. So glass material will be, so it will be cube or cuboid like that, one glass to be taken. That refractive index we can find. And for verifying this required operators, the operators needed for verifying this is one glass slab is important one, and to consider drawing board, drawing sheet and pins. Drawing board, drawing paper or white paper, whatever you say, or fix up the pins finger. These are the required operators for verifying this experiment. Now, what are the arrangement of operators? Arrangement of operators. First of all, take one glass slab. Before that, to place horizontally this drawing board and fix to that one white paper, and it is fixed to the white paper with the help of the pins, and place one glass slab at the center of this paper and draw its outline. First of all, to draw its outline, suppose this will be shifted. Again you have to place that same position this times. That's why compulsory you have to draw the outline of this glass slab. So this glass slab outline to be drawn. Remember, after drawing this outline, so name them A, B, C, D. So this glass slab is considered as A, B, C, D is a glass slab. And here to consider two normal lines here. One is 1 and another one to be considered like that. So here what happens, two media will be taken. One is A, another one is glass. Here what happens, the ray first taken from A with certain incident angle. To be taken, and that light falls on this glass, there it will be refracted. After that again it comes out because it is not closed, it is open. Glass slab, glass completely transferable, transparent material this is. That's why again the ray comes out, here. That ray we call as emergent ray. Remember that the ray which comes out after this diffraction is said to be the emergent ray. Okay. So now first of all to take one incident ray. So one incident ray produced from the source. So here one incident ray to be considered with an angle of 30 degrees or 20 degrees, whatever you say, it is an angle of incident. With angle of incident it will be taken, and what happens, it will be passes through glass wedge and making with an angle of refraction, or from there again it will be emerges out. This is called emergent ray. It's an angle of emergent ray we call as. This is the refracted ray. That means first to draw incident ray, next it will be refract like this. It is refracted ray. From there again it will be emergence. So this is the emergent ray. refracted ray incident time. That to me. And before conducting this experiment, we find the thickness of the glass slab. So this glass slab, this glass slab's thickness to be determined. This thickness to be determined with the help of screw gauge or vernier calipers. These are the devices to find the thickness of the glass plates. Okay, so otherwise spirometer also use it to find its thickness. Then after, angle of incident to be found. So when this angle of refracted ray will be passes parallel to this ray, that's called as, that means this emergent ray passing away from this wedge, that forms a lateral shift and vertical shift will be taken. Lateral and vertical shifts. Vertical shift is parallel to this vertical shift is perpendicular to the axis, and lateral shift parallel to the axis. Parallel to be formed, ray will be emergent, that's the lateral shift, and vertically it will be formed, that's said to be the vertical shift. So here vertical shift also to be measured. Okay. Then after, to find the refractive index, after determining this angle of incident and all of this, we can find the refractive index of glass slab. Refractive index of glass slab is given by the application. Thickness of the glass slab, thickness to be determined here, thickness of the glass slab. So already I told you thickness to be determined by finding the device. What is that? Spirometer, screw gauge or vernier calipers, whatever to be used to find this thickness first. So thickness of the glass slab by thickness of the glass slab minus vertical shift. Thickness of the glass slab. Thickness of the glass slab minus vertical shift. Vertical shift. By applying this application, we can find the refractive index of glass slab. So it is a glass slope. Approximately we get 1.5 its value to be determined. Okay. In this manner, we can find the refractive index of glass. By changing these angles, this also be this vertical shifts also be changes. Whatever the change to observe, for every time you get the same RL value, no change in it, because refractive index of glass will be same, that is 1.5 you get it. Okay, so this is about the simple brief description of this determination of refractive index of the glass. Now, in this topic we discuss about a few problems. So it's a very important one. So after completion of these problems, if any matter remains in CBSE, then I will continue that. So first I will finish this part. So here I had observed some important problems to be considered. Problems. First one to consider, the velocity of light in diamond is 1,24,000 km per second. So the velocity is the given question is the velocity of light in diamond is 1,24,000 km per second. The velocity of light in air is given. The velocity of light in air is 3 lakhs km per second. 3 lakhs km per second. Find the refractive index of diamond. RI means refractive index of diamond. So find the refractive index of the diamond. So this is the question. So for this we can make the solution. What is the formula for refractive index? N is equal to C by V. So remember the formula. If in some cases C value is not given, so C value is constant. Already I told you that's the velocity of light in air or vacuum will be taken as 3 lakhs km per second or 3 into 10 to the power of 8 meter per second. In the question, the C and V values are given. then we can find this n value. So once again we write the steps. So the velocity of light, in diamond is V. V is equal to 1,24,000 kilometer per second. Similarly, the velocity of light in A, that is C, is equal to 3 lakhs kilometer per second. Then we have to calculate the refractive index of diamond. So Ri of diamond, refractive index of diamond, n is equal to how much? So once again recall the application, n is equal to C by U. That is equal to C, 3 lakhs kilometers by 1,24,000 kilometers. 3 zeros gets cancelled. Now, to multiply with 4, 4 sevens are 28, 4 fives are 20, 4 threes are 12, 4 ones are 4. So 75 divided by 31. There is no cancellation. So to divide 75 with 31. So 2 times. 2 ones are 2, 2 threes are 6. So 3, 1. So keep point here to place 0. Now approximately it goes to 4 times. Approximately to consider as 4 times. Now, what is the value you get? 2.4. Refractive index is equal to 2.4 in diamond. Okay. So that's the refractive index of diamond value, right? 2.4. 75, 3, 7, 1, 13, 4 ones are 4, 4 threes are 12, 4 ones are 4, 4 threes are 12. So 6 remain. Already point is there 2, right? 2. So refractive index of diamond, therefore, write the conclusion, Ri of diamond. Ri of diamond is equal to 2.42. No units for this. Remember that. So no need to write any unit because refractive index does not have any unit. Okay. So to prove like this. So n is equal to C by application. Remember, velocity of diamond and velocity in light will be given. Then to calculate the refractive index, n is equal to C by V. So another one. This is the first one. Next to consider second problem to be considered. In this, the relative refractive index of glass, the refractive index of glass relative to water is, refractive index of glass relative to water is 9 by 8. Glass with respect to water will be 9 by 8. What is the refractive index of water? What is the refractive index of water relative to glass? The refractive index of water relative to gas. Relative to glass. This is the question. Now here, refractive index of glass, that is refractive index means N. Refractive index of glass with respect to water will be given as 9 by 8. Then refractive index of water with respect to glass. So to change the fraction. Very simple. So this fraction will be given. Water with compared to glass it becomes 8 by 9. Glass with respect to water becomes 9 by 8. So what does this means? So no need to write complete words to observe. Refractive index of glass with respect to water is 9.8. Then refractive index of water with respect to glass will be 8 by 9. Okay. Now another question to be observed. The absolute refractive index of water is 4 by 3. The absolute refractive index of third one, the absolute refractive index of water is 4 by 3. 4 by 3. Now, what is the critical angle? What is the critical angle? To find its critical angle, what is the critical angle? Critical angle to be found. So critical angle to be found means actually this critical angle values to be observed by trigonometrical ratios with sine and will be observed by logarithm books. But logarithm books are not there, so we can give it some values. So here what you get for making this, you have to get the answer sine inverse of 0.75. So the value of this sine inverse of 0.75 to be taken as 48 degrees 36 minutes. 48 degrees, this value will be 48 degrees 36 minutes. So to remember that, up to this you can make sine inverse of 0.75. This value will be 48 degrees 36 minutes. Okay. Now here what is the given? Refractive index of water, Ri of water. Ri of water, N is equal to how much? 4 by 3. Now critical angle. Critical angle C is equal to how much? What is the relation between them? N is equal to 1 by sin C, or otherwise sin C is equal to 1 by sin inverse of minus n. What is the n value? N value is given as 4 by 3. 4 by 3 is equal to, so to write like this, sin C is equal to, here to write sin C is equal to 1 by n. It is better to write easy. Now to make that 1 by n means 1 by 4 by 3. So that is equal to 1 by 4 by 3 means that is equal to 3 by 4 you get it. 3 by 4. So 3 by 4 means 0.75. What is this value? Sin C. Then C is equal to sin inverse of 0.75. So already it is given in the question. Sin inverse of 0.75 is equal to 48 degrees 36 minutes. Therefore C is equal to 48 degrees 36 minutes. Actually this value you get it from the logarithm book. To see the logarithm book, this sin inverse of 0.75, you get this values in degrees. Okay. So this logarithm book application is not in this class. That's why just provide some values will be given like that. So remember this values in question. In question it will be given actually. If not given, to remember this value, sin inverse of 0.75 is equal to 48 degrees 36 minutes to be considered. Okay. Then similarly, to be continue the another problem. In this, determine the relative refractive index of benzene if the critical angle is 42 degrees. So critical angle will be given. From that we can calculate the refractive index, n value to be calculated. In this question, n value is given to calculate C value, but in given question, refractive index of benzene to be determined, the given is the critical angle of benzene is given. So what is the critical angle of benzene is given? So here to